Section 2.7 is on proving segment relationships. First thing we need to talk about is something called the segment addition postulate. And it says if points A, B, and C are collinear, then B is between A and C, if and only if AB plus BC equals AC. We're going to use segment addition postulate if we have three collinear points, and basically what it says is this little segment AB, its length plus the length of this segment here, BC, adds up to the large segment AC. And we did a little bit of this in chapter 1. We did some examples like this, but basically the length of AB plus the length of BC equals the length of AC. And this will be a very useful postulate when we do some proofs. And let's try a proof right here. So it's given that segment AC is congruent to segment BD. So from A to C is the same length as from B to D. And what we have to prove is little segment AB is congruent to little segment CD. And you might look at that and go, well, yeah, that's kind of obvious. But you can't say that in a proof. You actually have to go step by step and show that that actually is true. As with an algebraic proof, the first step is always to state the given. So segment AC is congruent to segment BD. And the reason for that is given. Okay? Well, here's a little hint. Since we just learned about segment addition postulate, we're probably going to be using that. Notice that any time that we use an equal sign, like we do in segment addition postulate here, we're talking about the lengths of the segments. There's no line over the top. But here, since we're using a congruent sign, I have a line over the top, so I'm saying the two segments are congruent to each other. So I need to get rid of that line over the top. So if segment AC is congruent to segment BC, then the length of AC is equal to the length of BD by the definition of congruent segments. Definition of congruent segments says I can go from a congruent sign to an equal sign, or from an equal sign to a congruent sign. The next thing I'd like to say is segment AC is kind of this longer segment right here. I would like to say that segment AC, the length of AC, is made up of AB plus BC. And I'd also like to say that segment BD is made up of BC plus CD. And that is segment addition postulate. Each of those longer segments is made up of two smaller ones. Okay? Now what I can say is notice, let me use a little bit of color here, that might help. This is AC, this is AC, and this is AC. This is BD, here's BD, and here's BD. So if AC is equal to BD, AC is equal to BD, and this is equal to this. Another way to look at it, if pink is equal to purple, then pink is equal to purple. So I can say AB plus BC equals BC plus CD. I took what was in step number 2, and instead of AC, I substituted AB plus BC. Instead of saying BD, I substituted BC plus CD. And that was the substitution property. Okay? Now, I have that AB plus BC equals BC plus CD. Do you notice the same thing on each side? If I were to subtract a BC on each side, I'd be left with AB equals CD. Just think of it like an algebra problem. Subtract BC on both sides. And that would be the subtraction property. Okay, now, it's always good when you're partway into a proof to look back. What am I trying to get to? I'm trying to get to segment AB is congruent to segment CD. Well, I'm almost there because I've got that those two segments are equal. So I think I can just jump there and say that they are congruent to each other by the definition of congruent segments. Remember, definition of congruent segment says I can go from a congruent sign to an equal sign, as we did between step 1 and 2, or I can go between an equal sign and a congruent sign, as we did between steps 5 and 6. And I'm done. I've proved it. Let's try and, before we do that, let's take a look at some properties of segment congruence. Reflexive property says that if segment AB is congruent to itself, obviously. Symmetric property says that if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. And the transitive property says if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Okay? Let's try another proof. This one gives us another diagram here. And in fact, it's a triangle. It's given that BC is congruent to DE. Let's mark that on the picture. BC is congruent to DE. It also says that AB is congruent to AD. So what we have to prove, so the two little ones on the bottom are congruent to each other, the two longer ones on the top are congruent to each other, and we have to prove that AC, the whole left side, is congruent to AE, the whole right side. Okay? So let's start by stating our given. BC is congruent to DE, and AB is congruent to AD, and my reason for that is given. Now, I have a feeling I'm going to be using some segment addition postulate here, or some addition or something like that, so I better change all my congruent signs to equal signs. And to do that, I'm going to use the definition of congruent segments. Okay. So I just changed congruent to equal. Now, if I take, and it doesn't matter which one, let's take the second one here, AB equals AD. What I want to do is I want to add BC to AB, and I want to add DE to AD. I want to take BC and add it to this side. I want to take DE and add it to this side. So can I do that? Yes, I can, because BC and DE are equal to each other. They're the same thing. So I'm basically adding the same thing to each side of the equation. I'm taking the basic equation AB equals AD that I had here, and on this side I'm going to add a BC, and on this side I'm going to add a DE, and since BC and DE are equal, I can do that, and that's just the addition property. I'm adding the same thing to both sides of an equation. Okay. Step 4. Well, let's take a look at this. AB plus BC, isn't that the same thing as AC from our picture? And AD plus DE, isn't that the same thing as AE? It is, and that would be segment addition postulate. Okay, so this right here, AB plus BC, is the same thing as this right here, which is the same thing as this right here. AD plus DE, I have another AD plus DE here, and that's equal to AE. So again, in step 3, if the pink stuff is equal to the purple stuff, and this is pink stuff in step 4, and this is purple stuff in step 4, then I can say, if pink equals purple, I can say AC equals AE. Again, pink equals purple, all I did was to substitute. I substituted AC in here for AB plus BC, and I substituted AE in here for AD plus DE. Now I'm very close to what I have to prove. All I need to do is a definition of congruent segments. Move that down just a little bit more. and I have gotten to what I have to prove. Okay, and I'm done with that proof. Let's try one more. This is kind of like the first one we did, but it's a little bit different. In this case, we're saying AB is congruent to CD, so the little segments on the end are congruent to each other, and I have to prove that AC is congruent to BD. You see, this is kind of backwards of the first one that we did. We started with the longer segments. We were given that the longer segments were congruent, and we had to prove the smaller ones were congruent to each other, and now we're doing it in reverse. So it's a little bit different, but it should be fun. So start with your given. And I have a feeling I'm going to be using segment addition postulate again, so I need to turn that into an equal sign. And I do that with definition of congruent segments. Okay. And now here's kind of a strange step. I can see that I've got AB here, and I've got CD here, and I know that BC is going to be a part of each one of those. In fact, I think I'm going to want to add a BC on the left and add a BC on the right. Sometimes before I can actually do that, I need to state the obvious, which is that BC is equal to itself. And that's the reflexive property. Now that I've stated that BC is equal to itself, I can add it to both sides of the previous equation. So I'm going to take AB and add a BC to it. And I'm going to take this CD and add a BC to it. And to make it look nice, I'm just going to put it in front. And that was the addition property, because I added a BC to both sides. Now, what is AB plus BC equal to? AB plus BC is equal to AC. And BC plus CD is equal to BD. And that's our friend, segment addition postulate. Okay. And maybe you can start to see where I'm going with this. I think I can use those. So I have, again, I'll go to my purple and pink pens here. AB plus BC, and there's an AB plus BC, and AB plus BC is equal to AC. There's a BC plus a CD. There's a BC plus CD, and I know by segment addition postulate that's equal to BD. So now I can say if pink is equal to purple, then pink is equal to purple. AC is equal to BD by substitution. And let's take a peek at what we're trying to prove here. We are like almost there. So what we have to prove is AC is congruent to BD. So let's do a definition of congruent segments to make it look exactly like that. And that's how you do segment proofs.